Can you guys see my screen? Yeah.
Yes, we can see your screen.
That's great. So we covered basic data types in Python, and we discussed four basic data types: int, float, string, and uh, uh, and Boolean. So these data types are there to facilitate different types of operations. So obviously, we cannot perform arithmetic operations on string. We can perform arithmetic operations on integer and float. We can also compare integers and float. And what do you guys think? Can we add Boolean types? So can we perform arithmetic operations on Boolean, like addition, subtraction? Can we perform addition, subtraction on true, false?
I don't think so.
Why? We can, because true under the hood is represented as 1 and false under the hood is represented as 0. So let me confirm it, because
Okay.
I'm saying it on the basis of my knowledge in R programming, but I think so. Let's do it. So here is true plus false. So I should get 1. Yeah. So true is 1, false is 0. So if I add another true, I should get 2. So yeah, so you can perform arithmetic operations, basic arithmetic operations on true, false. So it's very important why different data types, understanding different data types is important, because we can perform different type of operations on it. Like string, we can convert the string into uppercase or lowercase or title case, or we can like uh, perform like whether we can check whether this string starts with letter T or C or K. So yeah, so that's why it is important to know the data types, because we can perform different types of operations on data types, and that's why we have different data types. So yeah, and today we will be covering the Python's data structures like list, tuple, dictionary, set. And these are very important data structures or data collections, or data containers as they are called. Uh, yeah, and but before that, we will also cover conception of variable in Python. So variable holds a reference to a memory address. So just keep this definition in mind. We will explore this definition more, um, uh, and slowly it will sink into your mind. So let me erase it. Okay. Okay. So yeah. So we were here. We were here. Okay, so the Boolean context, so some non-Boolean values also have a Boolean context. That's very important. So like positive, negative, it is considered as true. Positive or negative value is considered as true. So bool, yeah, there we have. So this minus 5.2, this positive value, this again float, this obviously this, all these values give you a true. Okay, so if I run this cell, you will see that yeah, so all of them give you true. And if I convert it into this value 0, so I will get false. Okay, so yeah, these are the so like numbers, non-zero numbers have a Boolean context. And if you replace this 0 with a empty string, so empty string, non-empty string is true, so empty string is false. So let's see, it's false. And if I put something in it, Imran, um, it will be true. So yeah, it's very important to understand uh, the Boolean context of non-Boolean values. So this should you should keep in mind. And obviously, we will also study composite data structures like lists, tuples, set, dictionary, and non-empty built-in composite data structure is always true. So non-empty list is true, non-empty a tuple is true, non-empty set is true, non-empty dictionary is true. But if they are empty, these data containers are empty. If by empty I mean if they don't have any element in them, then it would be false. But yeah, so let me let me erase this. Okay. Okay, so obviously bool 0 will be what will be it? What will it give you? What do you think? It
False.
false. False. Yeah, 0
Yes.
is always false. So this is an empty list, and this is a list having an element. So this empty list is obviously true. Yeah, I think so. And non-empty list, this non-empty uh, list is true, and this is false. So false true. Yeah, false true. So yeah, these are important. These are important, like to understand. Okay, assignment operator. So this assignment operators, you will of all the assignment operator, this is one you are going to see the most. So single equals to. So this is how you create a variable, and we have created the variables multiple times. So if you want to create a variable, like maybe this is a equals to 5. So a is the name of a variable and 5 is the object. Okay, so this a holds a reference to this object. So this object like 5 exists in some memory location. Okay, so what is this behind? You can visualize it. Let's suppose that this box is a memory location, and this 5 exists in this memory location. So what is a? So a points or a points to the uh, object in the memory location. So this is what. So a we also say that a holds a reference to the object in memory location. So object is 5. Okay, or maybe there is another b variable which holds a reference to some string, maybe uh, mm, so this is a string pq. This pq exists in some memory location. So what is this b? B holds a reference, so it is pointing to the object pq in a memory location. So how do you create it? You create it using single equals to sign. And remember that single equals to is different from the doubles equals to. So that's very, very important. Single equals to sign is not the same as double equals to. So I mean, we will not like these are some other assignment operators. Plus equals to, minus equals to, ecstatic equals to, and slash equals to. So yeah, but obviously we use them in for loop or inside the function. So when I will cover functions, I will discuss them again. So what you this is the most important assignment operator, singles equals to, and it is different from the doubles equals to. Doubles equals to is different. Okay, and double equals to checks the equality of the two objects. Okay, okay. Let me okay. Let me raise it. Uh, so again, so variable is a reference to an object in memory location. So that's very important. So yeah, so that's very important. Now we are going to cover maybe the most important identity operator, in a sense that it's little difficult, but it is very important. So we have we have identity operators like is and is not. So these identity operators are very useful. So if you want to check whether the two objects share the same memory or whether the two objects are the same or different in the memory. So you use is and is not operator. So let me give you an example. I mean, example will be very important. So I will stress uh, I will stress this a lot throughout this course because identity operators are important in a sense that it gives you an understanding how the memory is managed at the lower level. So uh, let's suppose that, okay, so this is uh, X, we are assigning 2020 to the variable name X, and we are assigning 2020 to the variable name Y. So what it is doing, what this is doing behind the scene. So this is basically, so just imagine that you have two memory boxes or memory locations. So this is one box, this is another box. So you have 2020 in one box and 2020 in another box. So if I ask you, so this is X, this is Y. So do you think that uh, these X and Y are pointing to the same object in the memory, or they are pointing to the distinct object in the memory? What do you think?
Same object.
No, in the
No, I
memory.
think they are distinct.
Yeah, in a memory, they are, so this individual box is different from this individual box, though the values are the same in the boxes, but they are two different boxes. Okay, they are two. So X and Y, they don't share the same object in the memory, though the values are the same. Both have value 2020, but they are not the same object in the memory. They are different, they are distinct object in the memory. So the 2020 associated with X resides in upper memory box, and 2020 associated with Y resides in at a different memory location or a different memory address at it is called. Okay, so it's also possible, let me erase it, let me erase it first. Okay, so now you have, let me do this. Okay, so if I use some other color, I think yellow is very, so. So this is a memory box, and here I have Python. So I have a string Python, okay? So now this A is a variable, and we have another variable C. So what do you think? Like both A and C holds a reference to the same object in the memory, or it is referencing to the different objects in the memory? What do you guys think?
The
Some
same
objects
object.
in memory.
Yeah, same object in the memory. So that's very, very important. So because this exists, A and C are referring to the same object in the memory. Yeah, so is operator will check whether the two objects exist at the same memory location or different memory location. So if you get true for this is operator, it means that the two objects exist in the same memory location. So this type of assignment statements created, though like we are binding 2020 to X and we are binding the same value 2020 to Y, but these two values, the X and Y, are referencing to the distinct objects in the memory. So double equals to sign will give you true, but this will give you false because this is checking whether X and Y exist in the two distinct memory address or not. Then this is what this code, this line is answering the question whether these two X and Y are distinct objects in the memory or not. So they are distinct. So you will get false. Okay. So yeah, let me run this code. Let me erase it. So ID function, what is the ID function does? ID function gives you
But
the
sorry,
go
to
ahead.
understand better, can you give us example using each operator that it will give true values?
Say it again, please, because I was my volume was low. Now again.
Okay, so I say that to understand it better, can you give us example using each memory that it will give the same value? I mean, the result should be true.
Yeah, so I will give you a lot of examples basically. So first I will discuss this, and maybe we will have more examples on it. So let me run this cell, x equals to 20, and this doubles equals to what does this do? This checks whether the two objects have the same value or not. This checks whether the two objects have the same value or not. And even if they are, even if they exist in different parts of the memory, if the two objects have the same value, it will give true. So you can see that X and Y, though they exist in the two distinct memory location, their values are the same. So this will give true. So this equality of the object is independent of the memory location. It does not bother about whether they are the same objects in the memory or they are the distinct objects in the memory. As long as their values are the same, as long as the values of X and Y are the same, the values which they are pointing, you will get the true. So so here, if I run this, okay, you will get true, and this will give you false. This should give you false. Why you're getting false here? Anyone? Why we are getting false here? Quickly.
Because they have different memories.
Different entities.
Different memory due to because
Yeah.
both are not in the same memory location.
Yeah, so they are not in the same memory location. They are in the different memory location. So that is very important. So that's why we are getting false. And ID give you the memory location. You can confirm the ID of ID function of X and ID function of Y. Their memory locations will be different. So let me show you this. When you run this ID function in your laptop, you will get a different memory location. So this number will be different for you. So here ID of X and ID of Y will be different because X and Y are two distinct. They occupy two distinct memory locations. They are not the same objects in the memory. So that's very important. Okay, let me let me delete this. Let me delete the annotations and also discuss this. Okay, second example. Second example is basically we are creating A is a variable name which is pointing to 2005. Okay, 2005 is an object that exists in a memory location. Then we created another assignment statement. So now B is also pointing to the same object in the memory. So what it is doing, let me show you with the help of a diagram. So first, you have this some sort of a memory location box. Here, the first statement, this statement 2005. So this basically created this. Okay, but when you assign assign A to B, basically what it does, it created another reference to the same memory location. So it created, so now B is also referring to the same object in the memory. So obviously the equality will give you true. And what about this A is B? You will get true or false this time?
True,
True. Why?
because it has the same memory address.
Yeah, because A and B are pointing to the same memory location. So A and B, so this statement, we did not created, this statement did not created a new distinct object in a memory. Basically, B is a variable, is holding a reference to the same object like 2005 in a memory. So that's important. That's something very, very important. So this will be, you can confirm with ID function. ID function give you the memory address. So ID of A and ID of B should be equal. Okay. ID of A. Okay. Why I'm getting this error? Quickly.
Because you didn't run A.
You haven't run the first one.
Yeah, that's great. So I did not run this. I should have run this. I should have, then yeah, you can run even this. So true, true. Yeah, so this IDA and IDB are equal. So you can see that this number, let me, you can see this IDA and IDB gives the same. So A and B are the variables that are referencing to the same memory address. So it is referencing to the same object in the memory. So these two, A and B, are not A and B don't have, not only have the same value, but it is referencing to the same object in the memory. So this is confirmed by IDs. And I mean, you can always do doubles equals to. So this basically, this is. So is like this. Is operator is operator checks the IDs. Yeah, so this is basically is operator. Okay, so what it is operator do, whether the two objects have the objects share the same memory or not. Okay, yeah, so that's that. Yeah, so yeah, okay, any questions? I mean, it's very important for you guys to ask questions. If you are not understanding, don't worry about it. Ask questions. And if like you, different students are participating from different parts of the world. So if language is a problem, no issues at all. You should comfortably ask questions. So that's very important. Otherwise, I mean, there are better videos on YouTube. You can go watch those videos. Uh, Self-learning. So my job is that you should all feel comfortable asking questions. Yeah. So is there anyone who can summarize this concept, the concept of identity and equality, equality of the two objects versus the identity of the two objects? Do you guys want to summarize? Anyone want to summarize what we have covered quickly? What does is operator means and what does double equals to means?
So the equal operator assigns a value to a variable. Then the double equal, the equality tells that the other variable is equivalent to the other. But which, when you are looking at the identity, you are looking at the location memory of
Yeah,
each.
so yeah, that's great. So when you are looking at identity, when you are is operator basically checks whether the two objects share the same memory or not. So that is what it checks. Okay, and doubles equals to check irrespective of where the two objects exist in the memory, whether the two objects are equal or not, whether the values of the two objects are equal or not. This is what is tested by doubles equals to doubles equals to. So yeah, so it's very important. It's very important to, yeah, yeah. Okay. And also you have to also remember that like these I will explain you later, but for now,
Excuse me.
yeah, go ahead.
Excuse me, member.
Yeah, go ahead.
Okay, maybe I'm missing the point
Yeah.
because it said normally if maybe I say A is the variable. If you put an equal sign, then it means you are assigning the variable on an object. If it is A is equal to 20, that means A is the variable and the equal sign is the object which is. And what did you say when the equal signs are the concept of A is equal to 20? That one I've gotten it clearly. What if you use two equal signs? What does it mean?
So equal signs.
I think I missed it.
So equals double equals to sign. So okay. So first of all, we have a single equals to sign. We have double equals to sign. We have is operator. So single equals to sign is an assignment operator. So single equals to sign. This is how you create a variable. Okay. You will see singles equals to sign a lot. So we have. Let me show you all the instances of single equals to, doubles equals to, and identity operator. So before I answer your question, I came here just to uh, share a small fact with you. All these basic data types are of immutable type. So they are immutable. So you don't have to worry, what does this mean, mutability, but just remember that these basic data types are immutable data types. And we also have mutable data types. Okay, now coming back to your question. So thank you for asking this question. I mean, I totally understand that it can cause confusion initially. So we have like singles equals to, we have double equals to, we have identity operator. So single equals to, here, let's suppose that single equals to is an assignment operator. Okay, so assignment operator means that you can access this object 50 with this name integer. So that is what is meant by single equals to. So if I type integer 1 on the next line, you can access the 50. So it lets you, single equals to is an assignment operator, and it lets you access an object no matter where the objects exist in the memory. Double equals to check the identity of the, double equals to check the equality of the two objects. So let's suppose that if you have this maybe I should use another color. Yeah, so if you have like q is the variable. So maybe maybe I should give an example of R. So this Q, like this is what I meant. So Q, when you run code in Jupyter Notebook, basically this is happening behind the scene. Okay, so Q is a variable which holds a reference to the object R in a memory. So this is what it is happening. So let's suppose that you created another object P, run another like assignment statement like P equals to R. So this is basically P is equal to R. So you run. So now basically this is another P holds a reference to a distinct object in a memory. So though the values of these two objects are the same, but they are distinct object in the memory. So this creates a distinct object in the memory, and you can access this object R with this P. You can access this R which is located at a different memory location with Q, and this happens with a single assignment operator. So, but if you check the equality of the two variables, so what do you think? What you will get? P doubles equals to Q. If I do this, what will I get?
True,
True. And why?
because they have the same values.
because they have the same values. Excellent. They have the same values. And what about P is Q?
It will be false
Why?
It will be false.
because they have different memory location.
So they have different memory locations. So yeah, that's what you excellent. So excellent. So yeah, and this is important. You will see memory management. I did not intend to go into the full detail of the memory management because like it's possible to understand Python without going into the detail of memory management. But this is essential because you will have to study deep copies, shallow copies, copies all the time. And whenever you are reading any blog, you will hear this lingo. So you should be very clear about this lingo. So I will also explain. So another term, copy. So copy is something that has an equal value but distinct memory location. So you can see that say that um, like uh, P is a copy of Q. P is a copy of Q. You can say because both holds the same value, the same values, but at a different location. So whenever you heard a word copy in Python, it has a special meaning. So what is a special meaning? Meaning is the objects have the same values, but they have a different memory location. So object has the same values mean that if you check with doubles equals to, you will get true. But if you check with is, you will get false. So that is what is meant by copy. So copy has a meaning in Python, and you should be very clear about it from the beginning. Okay, don't worry if you could not understand everything every bit of it. It will slowly sink into your mind. I will repeat this concept many times. Yeah, so maybe I will ask some student to summarize it, whoever wants to summarize this concept in coming lectures. So it's an important concept. Be clear about it, but it's okay if you don't understand it fully now. Okay, so let's move. And I also like integers, floating point numbers, string, Boolean types. They all are of immutable types. So they all are of immutable types. So I will explain what does this immutability. Okay. So now we will move to membership operators. So Python also have membership operator like in. In is a membership operator, and what it does, it checks whether the element is a member of a data collection or not. So let's suppose that I haven't taught you yet list, but this is a list. List we list basically we create it with square brackets and each element. So this is an element. You can think of it as an element, and each element is separated from the next element by commas. So yeah. So list is a sort of a data collection or data container, or yeah. So here we want to study about in operator. So in operator basically checks whether, here I'm checking whether 3 is a member of this data collection or not. So so what do you guys think, whether 3 exists in this list or not? Whether this 3 exists, whether we have a 3 in this list or not?
Yes, it exists.
Yeah, so in will check, this in operator will check whether, whatever is on the left exist in the data collection on the right or not. So this is what it checks. So so if I ask you whether 100 in number, so number is a name to a list. So what do you think, whether 100 is a member of this data collection or not?
False.
No.
No. So 100 in. So this is how you will write in this like. So you check whatever is on the left. So you can think of this left operand. So this is an in membership operator. Okay. So yeah, so it does not 100 does not exist in the list having numbers 1, 2, 3, 4, 5. So it should give you false. So we have in, we have not in. So if I ask you, what does this not in gives? If 100 not in, so 100 not in will be, it
True.
means true. 100 does not exist in this data collection. Okay, so we have membership operators. Yeah, so that's great. So you can check whether an element on the left is a member of some sort of a group on the right. So this element in the left of in operator is member of the group of right or not. So this is what you check with membership operators, very useful operators. And we also have membership operators in our programming. So yeah, okay, again, variables. So variables basically, so what is a variable? What's the concept of a variable? So variable basically holds a reference to the object in a memory, to some object in a memory. So this assignment operator is equal to create this numbers is a variable name, and this single equals to sign creates a reference to the list that exists in some part of the memory. So what is this variable? It creates a reference. So by reference, you mean that you can access this list by this variable name numbers. So if there is any question, go ahead, please.
Yes, I have got a question over here.
Yeah, go ahead.
As you have defined, you have defined five numbers in the numbers.
Yeah.
So I have this question that all these numbers have same memory location or different memory locations.
Okay, that's a very interesting question, and I will answer this question because in a list, list um, has one memory location. So this numbers will have a one memory location, and
Yeah.
this 1, 2, 3, 4, 5 will also have their own memory locations. So that's when we will study data containers, you have to hold this question, and we will discuss this it in detail. So, but it's a very interesting question. So here you can see. So obviously, this numbers numbers will have its own memory location, but each item in this list have its own memory location as well. Okay, so yeah, it's an interesting question, and when we will study, third or fourth lecture about mutability, we will study the idea of mutability in detail. So this thing, your question will become the basis of our lecture. Okay, because it's an important question, and we will see the idea of mutability.
Okay. Thank you.
Yeah. Okay, any other question? Don't hesitate to ask questions. Ask, no question is right or wrong. If you have any question, you should ask. This is how I learn from, yeah, this is the only way. Otherwise you can watch YouTube videos. Yeah, so yeah, that's very important to
As
ask
you
it.
are saying that numbers is a variable over here.
Yeah.
So a variable holds a reference to the object in the memory.
Yeah.
Then how the list 1, 2, 3, 4, 5 and numbers have different memory locations?
Yeah,
I don't understand this thing.
yeah, yeah, I will explain this concept, but not now. Or
Okay, okay.
this is not limited to list. This question is also relates to tuples. This question is also related to set. This question is also
Okay,
related
right, right.
this question is related to all the data containers. So list is not the only data container. So we have dictionaries, we have tuples, we have list. So yeah. So this is are interesting questions, and this will be become the basis of. And you just have to keep it in your mind, and keep asking this question. Yeah, and I will definitely come back to it. Yeah, it's a part of the program. Yeah. Thank you. Excellent questions. Okay, so variables in Python, obviously, I mean, there are some naming conventions. You cannot start the name of the variables like you with a digit. So I cannot name it in this way too, or no. It cannot start with a digit. Okay, so it has to start with the alphabet. And obviously, I cannot like a numbers list. They should not be space. So this is not valid. So you have to, maybe if you want to use two words, like they should be joined by underscore. So there are some naming conventions. It's good to follow the naming conventions. Yeah, how to name a variable. And variable again holds a reference to the object in a memory. So that is what it is. Yeah. Okay. Numbers. Okay. So yeah, so these, like, there are some naming conventions. So you just have to follow these naming conventions. Okay. Um, and Python is a very flexible language, very powerful language. You can create multiple assignments. You can create multiple assignments. Okay. So P, Q, and R holds a reference to the same object in memory. Okay. P, Q, and R is referencing to the same object. So if you check any two of these three objects with equality and is operator, you will get true for both of them. So let me so this is a it create multiple chain assignments. Okay, so yeah, so here if I, okay. So Python lovers, Python lovers. So this assignment space means P, small p, I meant to write Q, Q, R. So yeah, so P, Q, and R holds a reference to the same object in a memory. Obviously, yeah, so here, if I do this, let me run this. Let me, so what do you think what you will get? Here, what do you think what you will get?
It's true.
True or false?
True.
Yeah.
True.
True.
Yeah. What do you think what you will get?
True.
Sorry, what?
True.
Yeah, true, because they are holding the same object in the memory. So P is R. Yeah. So yeah. So this assignment operators. So you have to be clear in your mind what is going behind. Okay. So yeah, this is important. I mean, I'm not going to super detail because I teach programming from the viewpoint of data science, and we don't need to go um, in too much detail about programming. It's possible to understand and write code. Uh, yeah, but memory management, little bit of memory management is important for from because of the even if you are studying NumPy's copy, shallow copy, deep copy, TensorFlow. So I mean, that's important. Yeah, that's why I'm discussing. Okay, now usually it is expected whenever you are teaching Python, it is expected that you will start from here. Okay, but I did not start from here. I like covered some basics. So now this is the core of our lecture. So we have 45 minutes and we will cover these things in detail. So these are called data structures. So first of all, these are called data collections, data containers, or data structures. Okay, data containers. So this we have different names. So you will see like this is data containers. Uh, so data collections, or yeah. So data structure is a way of organizing and storing data. So it's a way of organizing and storing data in a computer's memory. So that's very important. And these like dictionaries have key value pairs, set we will go in the detail of each data container, but we organized and store data in a different format. And this is so because to facilitate the accessing. So how to access and manipulate this data. So yeah, so that's what we that's important. So data structure is basically an act of organizing and storing data in a computer's memory, and the purpose is to and having different ways of organizing and store data is to facilitate the access and manipulation of the data. Okay, that's very important. Okay, first of all, we will start with a list. So I just want to give you a first overview of these data structures, and then we will go into its detail. So lists are ordered, ordered and mutable. So lists are ordered and mutable, and they can contain elements of different type as well as elements of the same type. So this is how you create a list. So this list is created with with square brackets. So here uh, 2 3.0 and 4. So how many elements we have? What is the how many elements we have in this list? This is 3.0.
We have three.
4.
Yeah, 4
4
elements.
elements.
So this is, yeah, 4 elements. So each element is separated from the next element by a comma. Okay, we have 4 elements in it. And what do you think about the data types? How many data types I'm storing in this list?
2.
2.
There are 2.
What are
So,
2?
hello.
Integer and floating.
Yeah, integer and float. Yeah, that's great. Integer and
So,
float. So
May
this
I
is,
get some credit here?
sorry?
May I get some credit here?
Yeah.
So when you say we have four elements, if we are to index these elements, won't we have 3 as the maximum number, since we are starting from 0 to when we are indexing, we are starting from from
Indexing.
0 to
Yeah, the indexing of obviously starts from 0 in Python, starts from 1, but the count of the number of the elements are 4. So if you count, indexing is we start from 0 here in
All right,
computer.
thank you.
Yeah, computer scientists love to start things from 0, and statisticians love to start things from 1. So that's a big difference between the two. Yeah. So we are storing 2 different type of data. It is possible. Python list can store, Python list is very, very flexible. It can store multiple types of data simultaneously. It could have stored like here, what I could do, I'm creating another list. So so this is now holding true. This is holding now maybe PQ as a string. So this is holding now maybe 50, and this is holding now 50.0. 50.0. So this is 50.0. So here you can see that this is float, this is integer, this is string, this is Boolean. So Python list can accommodate different type of data, and each each element is separated from the next element by a comma, but there is no comma for the last element. So okay, so yeah, so and obviously we create list with the uh, square brackets. And Python's even you can accommodate nested list as an element in a Python's list. You can store dictionary, you can store tuple, you can store set in list. So lists are very, very flexible. Even you can have functions stored in a list. So as far as what type of elements can constitute Python list. Very, very flexible. So that's okay. So lists are ordered. Okay, ordered. Ordered means that the order matters. Orders matter. So if I create, let me delete this. Okay, let me delete this and let me create a, where is it?
Yes, Mr. Imran.
Yeah.
Okay, sorry for the interruption. Someone has raised an idea on the chat forum, through the chat forum, that you create a WhatsApp group so that we can be networking, we can be asking questions. So, and people are already dropping their contacts on the chat side.
Yeah, I mean, yeah, this, I can share I mean, if everyone is comfortable with it, so you guys can go ahead. But yeah, but obviously, it won't be possible for me to be a part of that chat group and responding to queries there. But yeah, it's good. It's an excellent idea that students should able to assist each other in their learning journey. So I'm open to this idea, and yeah, if everyone is willing to be the part of that group, that's great. That's great. Yeah. So okay. So now we have a list. This is a list, and this list, there is another list, 3, 2, 1. 3, 2, 1. So both these lists contain same elements, but they are in different order. So therefore, for these two lists are not the same. They are different. Though the elements of these two lists are same, but they are in different order. That's why that makes them, these two lists, different. Okay. So yeah, so let me see, because I was not seeing. Yeah, I mean, yeah, it's excellent if you guys can. Yeah. Yeah. Okay. So lists are ordered. So order matters, because order matters. The list 1 to 3 is different from the list 3 to 1. Yeah. And lists are mutable. So that's why you can add, you can lists are mutable. So a list you can add, remove, append elements. Okay, so what's the difference between list and tuple? So the big difference, and probably the only difference between tuple, is that tuples are immutable. So you cannot modify tuple. You cannot add any element in a tuple. Other than that, tuples are behave in the same way as list. And tuples can also accommodate multiple type of data. It can also accommodate the same type of data. So there is no limitation on tuples as well. So that's important. Sets are unordered. So sets are unordered collection of unique elements. Though there are two properties of the sets, very, very important properties. So what are those properties? Sets are unordered and they contain unique elements. So you said, and by the way, we create tuples with the parentheses. Okay, though it's not required to create tuples or tuple, whatever you would like to call it, with the parentheses, but it's a convention that you should create it with a parentheses. So sets, again, sets, we create sets with this curly braces. Okay. So is it a set? What do you guys think? Is it a set?
No.
Yes. Yes.
Why? Yes. Someone who is asking yes, why?
Because sets normally have curly brackets in it, and with the elements, it can have elements and it cannot have an element. It can be without, it can be an empty set. But with curly brackets, we call it set.
Yeah. So sets must have unique elements. So one is repeated. So that's why we cannot call it as it's not a legitimate set. So the set must have distinct elements. So the definition of the set is it must have distinct elements. So if we are repeating an element, we cannot call it simply one will be removed. So only one will be kept in a set. So repetition is not allowed. Repetition is not allowed in set. So the elements must be unique. That's the number one point. And so what do you guys think about this set, these two sets? So are these two sets equal or not? So this is curly braces 2 1. So this is comma. Sorry, this is my comma. 3 4 1 2 3. What do you guys think about the two sets? The two sets are equal or not?
I think they are the same sets
Why?
because they have the same elements, but they are unordered.
Yeah, and order does not matter in set. So order does not matter in set. So as long as the sets have the same elements, we can call it we can call it um, they are equal. They are equal. So they are different from the list, because in list and tuple order matters. So if the list and tuple, the two lists contain same elements in a different order, they will be considered different. So they won't be considered equal. So that's very, very important. Okay. Uh, so this is sets. We have covered sets. Now dictionaries. So obviously I will go into it to super detail. I mean, this is very, very important topic, but this is just, I'm previewing the concepts. I'm just previewing. This is a preview. Obviously we will discuss it in detail, and we will see. Okay, dictionaries. Dictionaries basically are key value pairs. So again, you create dictionaries with the curly braces. So again, let me, how you are creating. List, you create with a square bracket. Tuple, you create with round brackets. Sets, you create with curly braces. Dictionaries and sets both are created with curly braces, but dictionaries have key value pairs. Okay, dictionary has a key value. So this is curly braces. And maybe you will say name, uh, name, uh, column. So name is a key. Maybe I will write my name, Imran. So after one key value, you are going to have a comma. So this is comma, and maybe I will write programming, second key. So programming, I will use a list, uh, maybe Python, R, net logo, stata. So these are some. So I mean, I'm not going to create all these. Python, R, and stata. Yeah. So each key value pair is separated from the next key value pair by a comma. So key, we have a key. This is key followed by colon, and this is by name, key value. So this is a value. So remember about the keys of the dictionary. Keys of the dictionary must be unique. So you cannot use the same key twice. So that's very, very important about the dictionaries. There are literally no limitations on the values of dictionaries. So dictionary value could be anything. So again, keys of the dictionary should be unique, and they should be of immutable data type. I will explain you what data types are immutable and what are not, what are mutable. So here list is mutable, tuples is immutable, dictionary is immutable, and sets is tricky. It must contain immutable data type. Okay, it must contain it immutable type. We will explore this concept of mutability. I don't want to make a general statement and confuses you, but yeah, so we will explore this concept of mutability in detail. So again, now let's can anyone summarize these four data structures: list, tuple, sets, dictionary? Maybe at higher level, what are the differences between these data structures?
Lists are ordered and mutable elements of different or same data type enclosed in square brackets. And if order matters a lot in a list. If we have same elements but with different orders, then they are two different lists. They are not same lists. Then in tuples are immutable. We cannot add any element in it, or we cannot modify. And in tuples are usually enclosed in parentheses. And sets are unordered, and they contain unique elements, and they are immutable. Or and Sets are different from lists and tuple, because in lists and tuple order matters, but in sets order doesn't matter. And dictionaries are key value pairs, and keys of the dictionaries must be unique, and there should be no repetition, as you said, of the values. And dictionaries should be immutable data type. This is what I understand.
Dictionary is a mutable data type. Dictionary is a mutable
Mutable.
data. Yeah, dictionary is
Okay.
dictionary is a mutable data type, and there is no limitation regarding the type of values used in dictionary. So
Okay.
value could be list, tuple, int, float, a boolean. It could be anything. So there is no limitation. But they on the keys, on the keys of the dictionary, there are two limitations. One, they must be unique. Second, they must be of immutable type. So the lists are mutable, therefore they cannot be keys in a dictionary. Tuples are immutable, so they can be a key in a uh, dictionary. Dictionaries Dictionary itself cannot be a key in another dictionary, because dictionary is mutable. So yeah, I mean, we will study it in detail. Excellent. I mean, excellent summary of what we have studied. So that's great. Okay, let me move this quickly. Okay, I don't know why my screen is locked. Okay. Okay. So lists are ordered. List can contain any arbitrary objects. Obviously, there is no restriction on the length of the list. So list can be empty, or it can be as long as uh, the memory in your, as long as your memory of the computer allows. So there is no restriction. So list elements can be accessed by index. So remember that any data structure in any programming language, if it is ordered, you can access it by index. Okay, so if the order matters, similarly, tuples are ordered or sequential data, so you can access tuple by index. And list can be nested to an arbitrary depth. Like, what this means is basically you can store a list in another list, in another list, in another list. So yeah, and we will see what does this mean. Lists are mutable. You can append, you can remove an item, you can modify an existing item. And lists are dynamic, so they can shrink, they can grow. So these are the properties of list. So why we can access list by index? Because lists are ordered. They are of sequential nature. They are sequential. If the dictionaries don't have the order, so key value pairs, there is no, if you cannot access the values in a dictionary by index, because dictionaries don't have order, so they don't have any notion of order. Sets, again, you cannot access elements, because uh, sets are unordered, so you cannot access it by index. So that's very important. Whether you are in R, whether you are in other programming language, if the data structure is sequential, it means that you can access it by index. Okay, so that's very, very important. If it is ordered or sequential, you can access by index. Okay. Index means that you can access it by a number. Okay, so this is a list. What is the length of this list? Can anyone tell me what's the length of this list? So the length is basically the number of elements. Yeah, number of elements in a list.
that are in the list.
Yeah. Sorry, say it again, please.
I say that they are four, the length is 4 because it counts
Excellent.
the number of elements that are in the list.
Yeah, excellent. Excellent. There are 4 elements. It's a list because we have created it with the square bracket. Each element is separated from the next element by a comma. All the elements of the same data type in a list. Though we are not required to have a same data type, we can have elements of different data type in a Python's list. Python list is very, very flexible. You can think of Python's list as R's list, which are also very, very flexible. Yeah. So, okay, why I'm getting this? Because I think I created A with 2005 previously. So I did not run this. Let me run this here. And I'm creating another list. So creating another list, you can think of this list. So this is the same. Uh, uh, all the elements are of the same type, but basically they are in different order. So you will get false. So A is not equal. If you are checking the quality of the two lists, they are not the same. They are different. And A is B. Obviously, what do you think? What you will get? Very important. And why? This, what you will get?
Um,
True or false?
False, maybe.
Why?
True.
false,
According to me, true.
false,
Yeah, someone who's saying false, explain it. Yeah.
because they have different memory.
Yeah, excellent. So they have different memory. So when you are creating A, this assignment statement created A references to this box. So I mean, I am not just imagine that this list exists in this box. Okay. So when you are using this assignment statement, you are creating another B. So they are at a different memory location. So these are two different lists. This is not equal. The element, so the quality test give you false, and identity test also gives you false, because these two lists are not only their elements are different, but they are distinct objects in the memory. So that's why you will get false if you are checking the identity of the two list. And the ID function this is just like is operator. Okay, is operator, and it will also give you false. So ID of B will not equal to ID of A. So if I run this, I will get false. Yeah, so I'm getting false. So that's very important. So if I okay, okay, okay. So now, what about how many elements we have in this list? Quickly,
4.
4. And what is the data type of these elements?
String.
Yeah. So what about this list? How many elements we have in this list? And what type
4.
of data? Yeah. Somebody else, maybe somebody else. How many data types we have?
4.
4. What are they? Quickly.
Integer,
Integer, float,
and boolean.
Boolean, and the
String. Excellent.
string.
Excellent. So, and we have another list. So, I mean, there is no restriction. We can have duplicated elements in a list. So here R is duplicated. In what data structure duplicated elements are not allowed?
In sets.
In a list.
Set. Excellent. So set.
In sets.
Yeah, we don't have no duplicate. So list puts no restriction. So here, this is a syntax for indexing. I mean, we are going to have a separate lecture on indexing. You don't need to worry about it, but you can access. So indexing, let me give you a basic difference between indexing and slicing. So indexing, if you are retrieving a single element from a data structure, that's indexing. If you are retrieving a subset of sequential elements from a list, that's slicing. So this is slicing if you are retrieving more than one element from a list. So in programming, so this is a start index, this is a stop index. So start index is inclusive, stop is not. So so maybe programming is this the name this list. So what it is like the index of this Python is 0, Java is 1, R is 2, 3. So this is, so if 0 column 3 means I will start from here, this is inclusive, this will be the part of the output, this will be the part of output, this will be the part of output, but 3 is non-exclusive, so this will be not. So you will see Python, Java R. So this is what you will get. Yeah, but obviously don't worry about it, indexing and slicing. So why I'm getting this error quickly?
Did you run programming?
Yeah. So yeah, so you will get back what type of data structure you will get back when you ran list, when you ran this, when you ran this code, slice it, you will get back a list, a smaller list. Okay, so you will get back a list. So very, very important to keep an eye on what type of data structure you will get back, whether you are using a function, whether you are using indexing and slicing. So it's a question of central importance. Okay, so what type of data structure you are getting back, that's something you should never forget. Okay, this is an in operator, a membership operator. So what do you think, what will, true or false? Do we have Python? So if I run this, what will I get?
True.
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 Yeah, because this Python is an element of the data container on the right. So Python is a data container's name is programming. So Python is, yeah. Obviously, we can have a, so how many elements we have in this list, nested list? Next cell.
4.
4. So the fourth element is a list. So this
It's
is
a sublist.
Yeah, sublist 4. This is third element. This is 2. This is 1. So as we have discussed previously, that a list are very flexible. They can even store sublists. They can store a nested list or tuples or dictionaries or functions, modules, anything. I mean, they are very, very flexible, very, very powerful in this regard. So yeah. Okay. So yeah, so this is basically interesting command. So this will tell you, anybody know what is the meaning of this command?
Please, can you please run the nested list? We want to see the outcome.
Okay, nested list. Yeah, there is no outcome here because it's an only assignment statement. But if you, yeah, this is how it's a nested list. Okay, so we, yeah.
Okay, thank you.
Yeah. So what about this percentage who? Do anyone know what it does?
For comment,
Sorry?
I think we use for comment if you need to comment something.
No. Basically, it is used.
But we need to take a remainder, I think.
No, it is percentage who, not percentage module, not modulo. It's percentage who. Basically, it checks all the elements, all the variables and functions in the namespaces. So see what it will give you. So how many of you use R programming? How many of you use R? Anyone who
I
use?
use R programming.
I use basic R.
Okay, basic R. Basically, it's what is in your environment. So it will give what is in your environment. Okay, so these are, so you have created nested list. There is a variable A, there is a B, P, and programming, Q. These are the variables. And even if whatever you have defined in a namespace or environment, this command will give you. So yeah, okay, yeah. Okay, clear. All right. So, okay. So, yeah. Okay. So here, basically, Python is in here. Python is, what do you think? What will I get here if I run this command?
I think true.
I think it's false.
No, false, false, false,
False.
Yeah, it will give you
false.
false because this membership
Yeah.
operator in cannot check by default. It cannot check what is in the nested element. So this nested list. So it cannot check whether what is in it this list. Okay, it's because it's a nested. So maybe you need to write some sort of a for loop statement to do that, and we will discuss for loop maybe in fifth lecture, so you don't need to worry about for loops.
Actually, the last element is not Python. The sublist is R and Python.
Yeah.
So that's why it's false.
Yeah. So yeah, but obviously if you are recursively checking within the sublist, then obviously it can give you Python. So here you are recursively checking. So you are looping over each element. So this what it is doing. So you are looping over each element in this nested list. So Java and if Python in object in that nested element, it will give you, it will print this. Okay. So yeah, so so you are looping over the elements. It's possible. So you can loop over dictionaries, you can loop over tuple, you can loop over lists. So you can loop over any object in Python if it has double underscore iter double underscore. If it has iter method, so then it is iterable. Okay. So you can loop over and you can perform list comprehension. You can, yeah, but don't worry about these things yet. We will study, but yeah, I just like, yeah. Okay. This is a list. All the elements are of the same data type. It has, its length is 3. So how do you know the length? So let me show you quickly. You can use len function, len a. If I run this, len a will give you the length of the list. So len takes any iterable. So list, tuple, dictionaries are iterable. Sets are, I think, also iterable. So yeah, but yeah, we will study it. Yeah. Okay. And so we know, so this plus operator is very interesting. This plus operator, we see this is used to add two numbers, but the what this plus operator will do depend upon the type of the operands. So here the operands are of type list. So it will concatenate the list. So plus is overloaded. So I mean, you can use plus here. Yeah. So if I bigger list, okay, bigger list. So this is okay. So plus does arithmetic operations if the two operands are integer or float. If the two operands are, I think it also works with string plus, and it also works with lists. So this programming and A both are lists. So let me. Okay, what happens? Okay, this programming is an operand. It's a list. Okay, so it will create a bigger list. So this elements of A will be added to the end of the elements in the programming list. So it will create a bigger list. So A has this 1, 2, 3, and these are added here. Okay, so it creates a bigger list. So let me do this. Okay. Okay, so here again our Python. So okay, yeah, this is not important. So you can check all the methods and attributes that exist for a data structure of particular type. So dir list will give you all the methods. So it's very important. So this gives you all the methods. And because it has iter method, list has iter method, you can loop over the elements. Yeah. So I mean, I will stop here today. I will stop here. Maybe we will cover. You can go through these lists at your own. Obviously, we will like study these. I will distinguish the methods and attributes, and then we will start from here and in the next lecture. But keep studying. And so are there any questions? Go ahead if there are any questions quickly. We have 6, 7, 8 minutes, and I will take questions. Or everything is understood, or nothing is understood.
I
Yeah,
have
please,
a question.
I have a
Actually.
question.
Go ahead.
I have a question about booleans and different types of variables. When do we need to define whether the variable is true or false?
Yeah, true or false. Maybe like yesterday we studied an example of Boolean, like for a driving test, you need two conditions. Both conditions should be true. You should be above 18, and you should be you should have a driving license. So I mean, you can think of a lot of situations where you need your data to be true false. Okay, where you need your data to be true false. Yeah, maybe if someone asks if you have a doctoral degree or not, so the answer will be true or false. So yeah, so you can think of these type of situations. Maybe if you are starting programming, you think that it's not Boolean is used rarely, but the Booleans are very important uh, data types.
Yes, that's why actually I'm asking, because, for example, in the lists, we can deal with different types of data, with different types of elements.
Yeah. Yeah. So we can perform different type of operation depending upon the data. So lists, we can perform different type of operation. If underlying data is string, we can perform different type of data. So it's very important to keep an eye on to understand data types, data containers. That's very important. Yeah. Any other question?
Please, I have a question. I have a question, please.
Go ahead. Go ahead.
Yeah, in R, we have data structures like data frames, table, matrices. I don't know whether it works here too, because I haven't heard something about
Yeah.
data frames and even arrays. I don't know whether it works also in Python.
Yeah. Python, obviously Python have pandas, and pandas is equivalent to tidyverse. So all the packages of tidyverse like deployer, reader, they are built in one big module, pandas. So the next step, if you want to use Python for data science, then you need to understand NumPy, pandas, matplotlib. Yeah, Python also have very powerful data science library. So yeah, and you can write very simple code for Python. Yeah, and yeah, good question. Comparison of, if you already know one language and you are learning a second language, so comparisons are important. So comparisons are important. In your mind, you should compare, like, oh, this list, what is a corresponding data structure to corresponding data structures in R or in other programming languages. How we do this thing in other language. Yeah. Question. Go ahead. Any questions?
Thank you very much. Thank you very much.
Yeah, no problem. So, I mean, guys, if you are not attending, then there is a possibility that I might not share the videos. So videos will be shared with only those students who will attend the class. So now, and you don't have to worry, like, to understand everything. I totally understand it's not possible to understand everything, but keep, like, spend 2-3 hours every day for maybe 1 month, and you will see the difference. Because I have taught a lot of students, and I can tell you with my experience that those students who are brilliant, but they like don't devote time, they never learn programming. I mean, they may be brilliant. Those students who are steadfast, who devote 1, 2, 3 hours over a longer period, and every day is a key. So, and like opening Jupyter Notebook, if you are using Jupyter Notebook, write some code, make mistakes, go online, use ChatGPT to find out what's wrong, but keep learning. So that's very important. And I must tell you, like, Python, I mean, increase your ability to get good jobs, no matter what is your domain. It's a sort of a skill. Programming is a skill required by all employers in everywhere. So it's very important, whether you are doing research, whether you're doing an academic job or industry job. Python is super important, and yeah, that's why a lot of people are learning it. So I will stop here today, and thank you guys.